Hello everyone. In this video we want to talk about the IDEA StatiCa Detail, which is for concrete design, and so Detail comes with two solutions. We call it Detail 2D and Detail 3D. So as it's clear from their name, so Detail 2D is dealing with the in-plane behavior of the surface areas, and Detail 3D deals with in and out of plane behavior of the surface elements. So just to give you a brief introduction about the implemented code in Detail application. So in IDEA StatiCa Detail 2D, so right now we have the American code and Eurocode, and so in Detail 3D we have the Eurocode only. And so because recently we just introduced this brilliant solution for let's say completing and finishing the anchor design that you cannot able to finish it up in IDEA StatiCa connection application. So right now, as you can see for Detail 3D, we have the Eurocode, but the good news for Australia market is that the Australian code will be added soon, hopefully in this year 2025. And so let's a little bit go ahead, just to understand what is the IDEA StatiCa Detail first of all. Then we will go to talk about the Detail 2D and 3D. So as you can see in this slide, so having Detail application, so you can go for designing different type of sections. Okay, so you can go for RC sections or RC design, reinforced concrete design. You can go for PT design, post tensioning. You can go for PC design, let's say precast design, and also you can go for CS or composite section design as well. And so having this kind of section, so you have actually all the possibilities to model the different sections. So any customized section, you have the templates, just to help you to come up with the speed of modeling. And you can add the opening. You can actually just go to model the reinforcement. So for the reinforcement, again, you have the templates, and you have the topology optimization, you have the reinforce optimization, and you can check the ULS and SLS check as well. So all the things actually possible in IDEA StatiCa Detail. And so mainly the purpose of using IDEA StatiCa Detail is to deal with the disturbed region. So let me just go back to the previous slide. So as you can see here, let me just so here we have the disturbed region, and also you have the Bernoulli region. So we call it D region and B region. So for B region, usually, we don't have any problem. And, almost any available solution in the market, they can design the B regions. What the problem or the issue is with the D regions. Okay, so once you have the complicated geometry, in terms of geometry, in terms of just variation of the loads, then so it's not that easy to deal with this kind of problem in let's say the general finite element solution that you have. So that's why IDEA StatiCa comes to the picture to help you to automate and complete the design process from the available solution that you have in your company. And then so you can just link them to IDEA StatiCa Detail or concrete and come up with the full design. So here you have some examples of IDEA StatiCa Detail with the disturbed region or with the discontinuity region. So for example, walls and panels, coupling beams, deep beams, pier caps, corbels, diaphragm for pre-stressing even, taper beam with opening, pile caps, dap beam. So you have all this kind of issue, which is really difficult to deal with if you want to do the manual calculation or go to check them within the spreadsheet or any other tools. So let's go to 2D. Okay, as we said, so you have the templates in IDEA StatiCa 2D, and it actually make the life easy for you, you can select the templates and quickly you can come up with the geometry of the section that you want to design. And also, you have some advanced feature just to simplify your model. However, just by keeping the let's say the advanced type of analysis, because here you can go for nonlinear analysis as well. But to keep the modeling simple, so you have actually the options just to define the proper boundary condition, which is support. Okay, so one of these options is just we have the actually the stiffness, and you can actually or let's say spring, and you can simply remove the columns, for example, and then instead of the modeling the columns, so simply you can add the spring at the proper location of the columns, and then so you can just come with the simple model. However, you have the effect of the column. And so as we said, so you can go for different type of limited state check for ultimate limited state and serviceability limited state. So you don't have any issue with this. Okay, so let me just go to IDEA StatiCa 3D. And here, this is the thing. And today, presentation is mainly focused on IDEA StatiCa Detail 3D. And as you can see here, so for those who are familiar with IDEA StatiCa connection or IDEA StatiCa steel application, so definitely you can design the steel sections in IDEA StatiCa connection or steel. Once we are thinking about the designing of the steel, so mainly we are thinking about the operations. Okay, so about the checking the bolts, welds, the plates, end plate, cleat plate, fin plate. So we are thinking about the operation design. Okay, so the main member, just will be designed in general FE solutions like space gas or ETAPS. Okay, but for the connection design, so we have the operations, as we said, like bolts, belts, end plates, cleat, fin plates, gusset plates. So those kind of operations can be design check in IDEA StatiCa connection. But in terms of base plate design, so you have actually kind of difficulties in IDEA StatiCa connection. That's why so we introduced the Detail 3D application just to get rid of those limitations that we have in IDEA StatiCa connection. And not only that, in 3D Detail, so you can add the reinforcement and you can check the anchor's capacity, considering the effect of reinforcement as well. So as you can see in this slide, so in IDEA StatiCa connection, as we said, so you can check the failure of the steel operations like gusset plate, bolt, welds, or whatever actually we mentioned earlier. But once it comes to the check the concrete block, for example, concrete cone failure, pull-out failure, or combined pull-out failure, concrete splitting, concrete blowout failure. Okay, so this kind of things, together cannot be done in IDEA StatiCa connection properly. However, to some extent, IDEA StatiCa connection gives you the results, but is not enough. So that's why Detail 3D application has been introduced. So here, as you can see, so by using the Detail 3D application, so you can just simply check the anchors, and doesn't matter so what geometry of the base plate or let's say the concrete you have, and again the number of anchors, the length of the anchor, so it doesn't matter. So just you can send the information from IDEA StatiCa connection to IDEA StatiCa Detail, and simply you can design them. As you can see here, so you have the effect of reinforcement as well, and that's why so you can simply come to check the anchors considering the concrete cone failure, pull-out failure, combined pull-out failure, and concrete splitting. So to some extent actually you can get the information, and so this concrete blowout failure can be done in IDEA StatiCa connection, but together, as we said, so in IDEA StatiCa connection you cannot go for all of these checks for anchors, but in IDEA StatiCa Detail 3D, so you can just have all these checks. So let me just go a little bit further. So here, after running the analysis for anchor check, so you can see the direction of the stresses in IDEA StatiCa Detail 3D. So just like this, you can create a section for having better insight about the specific region that you want to, just get the results. And yeah, so let me just go back to here. If you want to get more info about IDEA StatiCa Detail 3D, so you can simply use any browser that you are using and then search the keywords IDEA StatiCa 3D Detail, for example, here. And then so the first option that actually just appeared to me is full functionality of Detail 3D, and so I can just click on that link, and from here, so as you can see, you have all the information about the Detail 3D application. Okay, so I will leave it to you. So you have actually many published articles in IDEA StatiCa website itself. Even you can go to support and learning center. If you click on that, so here you can search about the Detail 3D, for example. Okay, so here I will say Detail 3D, and you can actually just get the information about the Detail 3D application. Okay, so you have plenty of information there. So let me just go back to here. So as you can see right now, I'm in the IDEA StatiCa connection application. So this is most probably familiar for everyone. Okay, so but here I have actually this base plate, let's say 4 number of columns that comes to this wall. And so if I run the analysis, so most probably I will get the anchor failure. But for this project, so I just let's say in analysis tab, I deactivate or set the concrete breakout resistance to none. If you go to none, so which means the software doesn't check the concrete block. Okay, so that's why you can, let's say just check the steel parts. Okay, but if you go to select the both or maybe tension or shear, so you may get some kind of failure for the anchors. So here, by the way, is none. So let me just accept this and then run the analysis. So I will show you another example that already is the concrete breakout failure set to both, and then we will see. So right now here, by having the settings of the concrete breakout failure as none, so here the anchors passed already, so and the capacity is 25%, so I don't have any problem with the anchors. And if I go to the check, okay, so here you have the anchor, and then so you can just go for anchor tab under check results, and then from here, so I will do right click and then print preview, and you can actually just see the information, but here there is no information about the concrete check. Okay, so now let me go to the second model that I have, which is here. So let me go back there. Okay, so here I can see actually the anchors already failed. The reason why I just in the analysis set the settings to concrete breakout resistant to both. Okay, so that's why here if I go to the check, by the way, here you can see all the anchors have issue. If I go to the check, and from here anchors, and let me just go for print preview, and from here, so you can read the information. So this is actually kind of let's say not usual cases. Okay, because here I have 4 base plated just coming to this concrete wall block, let's say. Okay, but once you have one, so you may get actually different kind of notification or report in anchor design. Okay, so let me again go back there And then so here it says that anchor groups at separate base plate interact with each other in one concrete block. So here we have 4 base plate. This is out of the scope of standard for anchorage design. Okay, so then the software actually now gives you more information about the design of this kind of things, and then so you can either do some further checking by yourself, or as we said in the previous example, so you can go to the settings and just set the concrete breakout failure as none. Okay, but definitely we want to check the anchors. We want to make sure the anchors actually can carry out the loads. So that's why here we can send the information to IDEA StatiCa Detail 3D. So right now I'm using the Eurocode. Okay, so here if I go to the let's say the code, so here I'm using the Eurocode. Okay, so as I said earlier, so unfortunately we don't have the Australian code for 3D detail right now, but the good news is that it's coming. So most probably just in a few months we have the Australian code, and the procedure will be the same. Since I'm using the Eurocode in IDEA StatiCa connection application, after running the analysis under check button, so here you have the RC check. Okay, so from here, so simply you can click on this option, and from here, so I will name it as let's say anchor design. Okay, and then so I will save it. So in just a fraction of moment, so you have the concrete block here, including the anchors. So here we are not going to check the steel part, so that's why the focus is to check the anchors. So before starting here, you have actually the notification, no reinforcement is defined in the model. So if I just want to make it simple for you, so here you have actually this kind of workflow. So you have the members. Okay, so here so you have the concrete block 1, and then so in terms of the support, so here you have the support, so you can specify the support at any region that you want. For example, here we have different phases. So here I have phase 1, phase 5. So that's why here you have the phase 5 or surface 5, and if let's say depends on the requirement or boundary condition that you have in your real project, so you can actually change the boundary condition. For example, here if it is this continuous wall, okay, so maybe you want to just change the or set the boundary condition at surface 3 and surface 1. Okay, so in this case, simply you can go to change this one to surface 1. Okay, just like this. You can take a copy of this, just as simple as that, and then so change it to this one. Okay, so right now you have two let's say boundary condition at surface 1 and 3. So let me just delete this one. So for this let's say demo purpose, I will go back to surface 5. So let's say here this is kind of the wall that you have, and so the thing is that you can go to transfer devices. So here you have the stiffening plate 1 for modeling this kind of things. So you can actually if you have any questions, so you can just let us know in the comment, and so we will come back to you and we will show you how you can model such a kind of geometry, or let's say the base plate with multiple plates. So we will actually create or make another tutorial for you, but it is quite simple in IDEA StatiCa connection application, and quickly you can come up with this kind of geometry. So here you have the stiffening plate 1, which comes from IDEA StatiCa connection, and then here you have all the anchors. So here it is anchor 1, 2, 3, and so on and so forth. And then so you can go to stiffening plate 2, and then you have the anchor 5, anchor 6, 7, and 8. And then so here you have the stiffening plate 3, and then stiffening plate 4. Okay, so this is about the transfer devices. And then so here also you have the loads and combinations. So if you go to here, as you can see, all the loads already we have it. It comes from the IDEA StatiCa connection. So if I go to here, you see, the all loads just automatically detected by IDEA StatiCa Detail 3D. And finally, you have the combination. So here you have the combination, and you can go to the edit option, and from here you can just edit it. By the way, here so you have only in IDEA StatiCa Detail 3D, so you have only ULS check. Okay, so the SLS check is not available so far, but again, we will implement this feature soon for SLS, serviceability limited states. Okay, so let's go to, let's say, the application, and then so here I will go to add some reinforcement. To add the reinforcement, so here you have the let's say the interface, and then so under design, so here you have the rebar assembly. If you click on that, so here you have the group of bar in 3D. So here just simply you can click on that, and then so again setting or placing the reinforcement is very simple. So you have the diameter of the reinforcement, material of the reinforcement, and then here you have the anchorage type. So you can just hover the cursor at top of each of these options or items, and then so you can get the information. Okay, so and you have the shape definition. So right now it is actually the straight reinforcement, so that's why here is selected. If I change this to standard bend, okay, so here you have the standard bend. And so let me go to the shape definition, and here it says that on surface edge you have by 2 points. You have the other options like on surface edge on more edges and on polyline. So I will prefer to use this one, on surface edge on more edges. And from here, so I will specify the surface cover. So if you go to, let's say this view, so here you have actually the surface cover, it is 20. So if I just make it more, for example 50, so you have something like this. And then number of layers. Okay, so if I go back to this view, so I will say that let's say right now I have one layer. So if I go to 2 layers, you see you have 2 layers, and then so I can go to, let's try 8, and then so here I will go for 250, and here also I will go to, let's say 12. Okay, and so I want to have the stirrups type of reinforcement. So that's why I will come to next option, surface component data. And from here, so the master element is the concrete block. So sometimes you have actually more than one concrete block, so which is another story. So but for now, so we have only one concrete block, so it says that CB1. And for the surfaces, okay, so we already put it at surface 1, as you can see here. So that's why the number of reinforcement is being developed in this direction, just perpendicular to surface 1. And for the edges, so right now we have on edge 1 and 2. So that's why here you can see that actually this is the edge 1. Here you have the edge 1 and edge 2. So that's why the reinforcement is being placed like this. So here we will say that edge 1, 2, and then here I have 3 and also 4. Okay, I will say 3 space and 4, and then enter. So now you have the close transfer reinforcement. Okay, so as simple as that. And so you have actually just other options. You can actually just go through them, and simply you can actually apply the necessary parameters to the concrete block. Okay, so now we have this, and then so we want to add let's say, the reinforcement in another direction. So that's why, again, so simply I will take a copy of this reinforcement, just like this. Okay, this time I will change the surface, maybe here to surface number 2. So I will say surface number 2, and then here, so you have the reinforcement, and again take another copy. So this time maybe we can actually now just select either surface 5 or surface 6. Okay, so here I will change this surface to surface 5, let's say. Okay, and then here, so I have this reinforcement as well. Okay, so here you have the let's say, the 12 layers, but don't worry about this, because the software is smart enough to understand the body of the concrete, and that's why, so never happen something actually out of the concrete block. Okay, and then so here we get rid of this issue. So the next thing that you need to do, so you need to go to the let's say, select the stiffening plates. So here, so just I want to make sure that the shear force transfer is being done correctly. So here we have the shear force transfer through the friction, shear lug, or anchors. Okay, so let me select the anchors. You have the multi-selection, so you can go to SP1, SP2, SP3, and SP4. And so that's why here I can select, for all of them as anchors. And then so the rest is, sorry, here is stiffening plate. And then so for the anchor, so here, I forgot actually to mention that if I go back there and if I go to, let's say, design option in IDEA StatiCa connection application. So the thing that I did here, so I just applied the 70 kilonewton meter downward moment and 25 kilonewton tension force, okay, for these 3 members. And for this last member, so the direction of the moment is exactly opposite. So let's say upward with the same value, minus 70, but the tension force is the same, 25. So that's why here, if I just go back to 3D detail application, so due to the moment, so and the axial force that I have, so here I need to check this option as well, the interconnection with the base plate. So I have the activation of axial force transfer and also for shear transfer. Okay, due to the let's say, the effect of moment that I have. So here I will just simply select these 2 options, active for axial forces transfer and for shear transfer. So now again, so I need to select all. Okay, so in this case I will press shift and select all of them, press control key, deselect the stiffening plates. Okay, and then here, so I will go to activate the, let's say, the interconnection with a base plate for axial force transfer and shear force transfer. So okay, so we have actually this, and that's all. So you are ready, just to run the analysis. So I will go to calculate option. Already I calculated this model, and actually now here you have it, but just to show you that the software, how the software works. Okay, so let me just cancel this. You can actually now go to settings and you can change the mesh size. So I forgot to do that. Just for the first running, so you can go to the settings, and from here you have the mesh setting, and by default is 1. So here I just prefer to have the 3 to have, let's say, faster analysis. And once after running the analysis everything is fine, so then you can come back to the settings, and then from here mesh settings, so you can just decrease the mesh size to have more accurate results. Okay, but for now and for this presentation purposes, so I will just put it at 3 and then run the analysis just to show you the speed of the analysis. And then So here the software is just go to convert the results. So it depends on the size of the let's say the concrete block and the forces that you have, so it may take time. But as you can see here is quite fast. Okay, so it should be done. Yeah, okay, so here we have the results. And yeah, so you are ready actually now to check the results. So for the result, you can go to the check tab here, and you have actually now the summary. So at the right hand side, so you can actually now look at the strength of the concrete, strength of the reinforcement, and also the anchorage length. So here you have this information, and also under ULS check, so here you can see the utilization ratio of the concrete, reinforcement, and also the anchors. If you go to the strength, so here you have the more detailed information, okay, for the concrete. So you have the minimum and maximum principal stresses here. You have the principal strains as well. Okay, so you have the triaxial stress factor, and also you have the direction of the stresses due to let's say the produced forces. Okay, so as you can see here, so we have actually some variation in the stress let's say directions. So exactly at this location, as we mentioned, so here we have actually this kind of results here. If I go to IDEA StatiCa connection, and under result tab I can go to just activate one of this option, let's say equivalent stress, and then here you can activate the deform shape. So here this is actually the deformation of the last member, and also the last base plate. Okay, so that's why you have actually this effect here as well. Okay, and from here also you have the detail information and values for each of these stresses and strain, and also the stress. So here you have actually all this information, the utilization ratio, everything. And then so you can go to the anchorage. Okay, so here you can look at the utilization ratio of the reinforcement and also of the anchors. And again, so in the tabulated format, you have all the information for the forces, for the, let's say, the bond stress. And here you have the ratio, the utilization ratio of the forces and bond stress, and, the all necessary information that we need. Okay, and if in terms of the let's say graphical result checking, so here you can go to this options, for example force check value. So here you can just click on that, and then here you can look at the forces in the reinforcement and anchors, and then so here you have the bond stress. You can click on the option, and then here you will get the bond stress. So for this anchors, brilliant results actually. And here also you can go for another type of check, which is total force in the bars. So here you can see all the forces in the reinforcement, and again so you have the utilization ratio or limit force in the bar based on the actually the ultimate capacity of the bars. Okay, and let me just activate this. Okay, so here you will get actually all this information, and so you can also look at the deform shape of the concrete wall block. So here you have it, and so from here so you can just play with the scale to see actually how it deform. You can look at the displacement in different direction, in X direction, Y direction, and also Z direction. So let me go back to, let's say, a strength of the concrete. And then, so here I'm interested actually now to look at this view. So here we have the location of the first three base plate, and then here the last base plate with the opposite direction of the moment. And if you want to have better insight inside the concrete block, so I can go to this option, and here I can create a new section. Okay, just click on that, and from here, so you can actually now just change the name as you wish. And also from here you have different views. So right now actually now I'm in the top view. If I change the view, so you have actually now front view, let's say back view, or maybe from the let's say any custom view that you want to create. So let me go to one of this view that I want to look at. Okay, so here, and from here, so simply I will go to, let's say, Y direction. So the thickness of the concrete that I specified here was 300 mm, and here, so you have the unit as meter. So here I will go for 0.15, let's say. Okay, and then here you have the location of the section, and then so I can even include this section cut into my report. So that's why here you can check this option and then apply, and then okay, so here you have actually now the section cut of this result. So you can go to other results as well, and you have the section cut. I can go to strain. Okay, so you have all this cool features. And so once you check the results, once you are satisfied with the results, so then you can go to the report, and from here, so I will generate the report. Okay, so here you have actually now the report, and so just you can look at the report and see actually now what kind of information you can get from detail 3D application. Okay, so you have all this information. This is the section cut that we created, and the software automatically include this section cut for each results. Okay, and yeah, finally, so you can export the report as the PDF format, or let's say editable Word format, and also you can link the software with the physical printer in your office. And yeah, so, and also for bill of material, so you can actually just go to the bill of material for the reinforcement, and you can just export the DXF of the reinforcement. So I think that's all for today. So please just let us know if you have any question, any comment, so we'll come back to you. And stay tuned with us for more tutorials, tips and tricks, and have a great day. Bye-bye.